So no bounds checking in C++, and I know I talked about that already. Meaning that if you try to access an element past the end of the array, C++ doesn't stop you. Now Java at least blows up with an exception. You know right away. C++, you may get an error, you may not. If you write to something past the end of the array in C++, you may get an error, you may not. But you can be sure that you're corrupting some memory somewhere, but whether that gets noticed by you or not, it's questionable. It's like, shooting an arrow up in the sky, and maybe it's going to hit somebody and maybe it's not. You're just not sure. So you need to make sure you're not writing past the end of the array. And what does writing past the end of the array mean? If you declare an array like this, int names is equal to, and you type in some values, and then you try to write something. That shouldn't be called names, right? It's digits. That would be an error, right? Because you can't have an index of -1 not in this language. It starts at 0, and it goes out to length -1. The length of this array is 4, so you can go out to index 3, 0, 1, 2, 3. So if you tried to write out, that, or you tried to do nums, 4 is equal to, 50, both of those would be out of bounds. Corrupting memory. Bad news. So the following code defines a 3-element array and then writes 5 to them. Why does it do that? Well, because size is set to 3, but then it goes for count is equal to 0, count is less than 5. So it writes 5 different values to it. Well, that's dumb. We had this 3 defined right here. Why didn't we just, use all caps size right there? But that was just to illustrate the fact that you could do it. Probably would crash the program. We demonstrated that on Thursday. So here we have memory block outside the array. This is before the array was allocated. Whatever is before that array in memory. And then we have some more memory after the array. This array was allocated to be 3 items long, so after these 3 chunks we have some extra memory dedicated to something else. And then when our for loop cooks along and writes out 5 values, it puts 3 there, and then it starts writing outside of the memory. When it says does not exist, it means it's not part of the array. It means it's part of something else. You don't know what it's part of. So be careful not to use invalid subscripts. Doing so can corrupt other memory locations, can crash the program, could lock up the computer, cause elusive bugs. All of that is true. Off by 1 errors. That's when you start counting at 1 rather than 0. Humans like to count from 1. So you say, okay, I'm going to change the first element of the array. So you write your code to do that. So you go, okay, nums 1. Equal to 0. I've changed the first element of the array. No, you haven't. You've changed the second element of the array. And then you go, okay, and I want to change the 4th element of the array. It's 4 long, so I'm going to do that. No. Now you've written past the end of the array. That's off by 1. You just have to remember computers, 0-based indexing, count starting at 0. And then when you're displaying stuff for users, if you have to put numbers next to them, you probably want to add 1 to it so that they see 1, 2, 3, 4 rather than 0, 1, 2, 3. But, that's up to you. Up to you and your users and whatever you negotiate there. I think I have too many things going on here. Yeah. Array initialization. You can initialize your array like this. This will look real familiar to the Python users and to the Java users, except in Python you use square braces to create a list. Same idea. I'm going to create an array of ints, and these are the 5 integers that I want to store into it. Something slightly different about this language that Java doesn't support is that you can set the size of it, and then you can allocate out just to the first few elements of it. You could say, okay, I'm going to create an array that's 1,000 elements long, and all I want to do is initialize the first 5 values. If you do that, then the rest of it's allocated with 0. So the values are stored in the array in the order in which they appear in the list. That's element 0, that's element 1, that's element 2, that's element 3, and that's element 4. The initialization list cannot exceed the array size. So if this array size was set to 3 there, but that we tried to set 5 elements into it, that would be an error. I don't know if it's a syntax error or a runtime error, but it's absolutely flat out an error. You can't do that. You can't initialize 5 values into an array that's only 3 long. You could fix that just by trusting the compiler. You remove the number between the square braces and you're saying, I don't know how long it is, I just want it to be equal to the length of the initializer list. That's how it looks, you know, in most languages. I almost never go and put a value here and use an initializer list. I do one or the other. If I have an initializer list, I don't care how long it is, and I let the compiler figure it out. That's 5 numbers. It's going to fill in a 5 there. Great. You know, I don't need to. And if I don't know what numbers are going to go there and I need to fill them out myself, that's when I'm going to declare an explicit length like that. All right. Kind of return that back to its former state. So the months of the year, 30 days, that's September, April, June, whatever. January's got 31 days, February's got 28 sometimes. March has got 31, April's got 30, you know, like that. Let's declare 2 arrays, one with month names and one with the number of days in that month. And these are going to be parallel arrays. Parallel arrays are when you have 2 arrays of the same length where the data is thematically linked by the index number. So here that's element 0, right? That's going to mean January. That's element 1. That's going to mean February. So let's create a program that has 2 different arrays. One with those days like that and another one with month names. This is C++ empty project. November 14. All right. Unsign include IOStream, all the good stuff. Alrighty, 2 arrays. One of them is going to be the array of months that we saw there. And there's no way that I actually remember those numbers. So if I can just copy that would be nice, but I can't. Okay, 31, 28, 31, 30. Thanks. So, int days. I'm not going to specify. Well, why not? How many months are there? Constant int months equals 12. And then int days, parentheses months, that's the size of our array, is equal to, and let's initialize it. Same value as they have. 31, 28, 31, 30, comma, 31, comma, 30, 31, comma, 31, 30, comma, 31, comma, 30, comma, 31. And then finally a semicolon at the end. Don't forget your semicolon at the end. Somehow I wound up adding an extra curly brace. So I just got rid of that so it'll compile. Now an array full of names. Month names. Which are strings. String months. I don't like using the name months when I have months as caps here, but whatever. How about just month? Parentheses months is equal to curly brace Jan, comma, Feb, comma, March, comma, April, comma, you know the drill, May, June, July, August, September, October, November, and December. That's a fancy way of formatting it. It could all be on one line, right? You don't need to put them all out like that. But these are parallel arrays. They both have 12 items. That enforces that, but even if they didn't, if we just counted, 4 plus 4 plus 4 is 12. And they're linked by their index values. January has 31 days. February has 28. March has 31. December has 31. November has 30. You see how they're linked by their index? So we can write a loop that'll print out the name of the month followed by how many days are in that month. I'm going to save a little bit of room by putting the curly braces on that one on the same lines. Now for our for loop. I'm going to use I as my index counter. We start at 0 and we go out to the length of the array. So while I is less than, I could type in 12, but I already have that stored in a variable, so I'm going to make it months. I is less than months. I++. C out the name of the month. Month subscript I has C out arrow arrow days subscript I arrow arrow space days \n. And again, you could put all that on one line, right? I'm going to run it and see. Rebuild solution. Run the debugger. Alright, it's not perfectly formatted, but it's got the right idea. January is 31 days, Feb 28, so on. I'm going to go and add that space so it's prettier. Just need to put a space there in front of that word has. Now it looks nice. That's the idea of parallel arrays. We could have another parallel array which was the rainfall for that month or the average temperature of that month, or if you do astrology, which month is Gemini. They don't actually follow on those months, but whatever, what birthstone is January, whatever, as long as it's of the same length and they are thematically united by their index value. Let's do another one with parallel arrays. This is going to be much shorter. string names is equal to Fred, Bob, Sue, comma, Jim. And then string foods is equal to pizza, corn, chips, and apples. Their favorite foods. Now write a loop that will print out Fred likes pizza, Bob likes corn, Sue likes chips, and Jim likes apples. Write another loop like this, except we need to know the number of names and the number of foods. Right? So let's go ahead and declare a constant. Constant int num names equals 4. Even if we don't use that when we allocate it, because this is allocating it out to 4, it's really nice to have that there. And honestly, we ought to stick this variable right here between the square braces. But go ahead and write a for loop. Work on that yourself for a minute, and then I'll do it. Don't type this. It's just what I want you to do. That will print Fred likes pizza, Bob likes corn, etc. All right, I want to play 2, so I'm going to do it. I need another for loop. I'm just going to reuse my I variable as the index counter. So for int I like I for index, I index, is equal to 0. I is going to be less than what? I know half y'all are finished, so somebody give me some help here. Num underscore names. Yep. Because I've declared it here, I may as well use it. I++. Now need to print out the name of the person, followed by the word loves, or loves to eat, whatever. Followed by some more arrows, followed by the name of their foods at subscript I, followed by E and DL. That's a lot of noise. All right. Fred loves pizza, Bob loves corn, Sue loves chips, Jim loves apples. Another example of parallel arrays. Arrays of the same length, thematically tied together by the index values. Fred pizza, Bob corn, Sue chips, and Jim apples. Put a comment here. Another example of parallel arrays. And I'm going to even put a definition of parallel arrays. Arrays of the same length where the elements are linked by their index number. good to go? Anybody need typing time? All right. If the array is initialized with fewer initial values than the size declarator, the rest of the elements will be set to 0. And that's kind of cool, because what is the array initialized with otherwise in this language? Well, let's find out. I'm going to create an array of ints called nums, and I'm going to set it equal to 10 numbers. If I don't know the length of the array when I print it out, I can usually calculate it on the fly by using size of. So int size is equal to the size of the array, size of nums, divided by the size of an int. Or what a lot of people do is the size of the first element in the array, which would look like this. But I don't see why we need to do that when we know that it is declarative ints. But here's what they do. Nums subscript 0, like that. It'll work either way. I think this is easier, right? Easier to type, easier to look at. Okay, so we can use that. For int I is equal to 0, I is less than size, I plus plus, and let's print out nums subscript I, arrow, arrow, ENDL. Now this array we have not initialized that array, and we haven't put any data into it. So what's it going to have? And the answer is you have no idea what it's going to have. It's not guaranteed to have any valid data in it whatsoever. If you compile it in debug mode, it fills it with this funny negative 85 billion number or whatever that is. If you compile it for release, it may have something else. I'm going to compile it for release and see. I'm going to change the compilation mode from debug to release. I'm going to do build, rebuild project. Then I'm going to do start without debugging. And look at that. We have no idea where those values came from, although they look like our months. That's pretty weird. That's totally weird. It's just by accident, though, that they happen to match our months. That's crazy. Yeah. Just what happened to be in memory at that spot. You have no idea, so you have to initialize them. In olden days, people would write an initialization loop like this. Just like this. For int I is equal to 0, I is less than size, I plus plus, and then they would say nums subscript I is equal to 0. Right? That would set every value in the array equal to 0. I don't care if you do it that way. I'd rather you do it like this. I'd rather you just say int nums is equal to 0, like that. Because in C++, unlike some languages, that that initializes every element in the array to 0. Or more technically, what it's doing is it's setting the first element to 0, and then the rest of them get filled in by 0, because that's the definition of what an initializer list does. If this has fewer items in it than the length, then the ones that don't match are all set to 0. So that's a quickie way of setting everything to 0. Set every element to 0. That's a shorthand way of saying what it's doing, but we know it's not setting every element to 0. It's setting the first one equal to that, and then the rest of them to 0. It's a fine difference, isn't it?
Can you scroll to the top of the code?
Sure. Where do you need to see? Further up?
Yeah. Just
to our months.
yeah.
Let me pause and come look with you. All right, guys, there's a big portion of the recording missing. I'll scroll up and down through the code, and it's going to be your responsibility to read the PowerPoint and understand what it's doing. But we've taken a right turn to talk about reference parameters. And so this is the code that we've come up with to test it. And down in main, we need to call test changes to actually see if this works or not. So I'm going to modify test main to have that. And then these are our functions. We have 3 functions. We have change me 1, we have change me 2, and we have test changes. And if you're typing all this at home, pause it, type it in. Make sure you get your call. Don't be fooled by the fact that I put my curly braces on the same lines. And call test changes here. But I made a mistake. Go ahead and compile it and find out what line the mistake is on. Rebuild solution. I mean, it could be more than one. Oh, look at that. It says rebuild all succeeded. I guess I'm sorry, guys. I was thinking of C#. Never mind. So this works just fine. When I run it, it should print out 1, and then the next line should be 100. 1, because this one wasn't allowed to be changed, because X is just a copy of what gets copied in, of the argument that's passed in. But when you declare a parameter with the ampersand sign, it actually means that this is the value being passed in. So we ran it. If I scroll way up here, as predicted, A was 100, was 1, and B was 100. Hope that's kind of clear. We're going to hit that topic again. But since we mentioned it in the for loop, we had to mention it again. Ampersand means that this is a reference to the original argument, which has some implications. What if we made that a constant, like a 5? Is it even thinkable that if you passed a 5 in there, that somehow the number 5, just the number, could be changed to 100? Are we going to rearrange the entire universe so that 5 is now equal to 100? No. So you can't pass a literal like that, a constant, into a reference variable. What if it was a constant int? I'm going to type something, but it's wrong, so don't type it with me. Constant x is equal to 1, and then I try to pass in x. That's not going to work because x is a constant, so how could it possibly get changed here? So I'm going to undo those changes. All right, and for the benefit of those who are watching at home, I'm going to scroll slowly through all the code, pause it, and type it in as you need. That's where we declare the days and the months. I think we had all that going. We have an array to print out the days and the months. Then we had parallel arrays of names and foods. We printed those out. That's how you create an array and set every element in it equal to 0, which is a good idea because otherwise you get garbage values in it that you have to set later. Then we talked about a couple different ways of printing arrays. You always have to have the size of it in order to print. You could calculate that size beforehand like we did here, or you could use a constant that you declared somewhere up above. We could have said, you know, if we knew the size of the nums array, we could have made a constant. 10, for example. Some constant equals to 10, and we could use that. Here's a loop for printing out arrays. Here's another loop, simpler, shorter syntax. Here's the simplest syntax, which is called a range-based loop, colloquially known as a for each loop. I will use that term probably more often than range-based loop. The advantages and disadvantages of using a for each loop. If you don't put this ampersand here while you're accessing the array with a range-based for loop, you can't change the values. Or you can, but they don't modify the array. However, if you declare this as a reference into the actual array, you can change the values as you rip through it. That's different than how it is in Python and how it's different. It's different for you Java guys as well. All right, hopefully you caught up. Processing array contents. We've kind of been doing that. Array elements can be treated as ordinary variables of the same type. What does that mean? You know, we had this array called nums that had 4 numbers in it. Wherever that went. Well, it has 10 numbers in it, actually. Scroll up to where you declared it, and let's change some of the values of it. So where it says int nums 10 is equal to 0, nums 0 plus equals, or plus plus. Now the first element is going to be 1, not 0. Nums element 1 plus equals 100. That was supposed to be nums, not num2. Nums element 2 is equal to nums subscript 0 plus nums subscript 1 times 2. Now that's a bit silly, but what's nums2 going to equal after all that is done? Well, what's num0 equal to after that's done? This actually increments the value that's stored in that memory. So it's no longer 0, it is 1. We added 1 to it. That's what plus plus does. Now element 1 was a 0 when we printed it out, but what does this do to it?
Plus 100.
Adds 100 to it, so the first element is a 1, the second element is 100. And so if we take the first element, which is 1, and the second element, well, PEMDAS, this happens first. Element 1 was 100, we multiply it by 2, so it becomes 200, plus what was in 0? 1, so it becomes 201. So when we print out our array, we should see the numbers 1, 100, and 201 repeated over and over as we printed it over and over. One, 100, you know. I don't know how many times we print out. Apparently only once. Okay. So you can use the elements of the array just like it's a single int. That is just a single int. The array isn't. Nums is a whole bunch of ints. But nums element 0 is a single element. It's a single int. And if it was doubles, it would be, you know, a single double. Stuff like that. So array assignments. To copy an array, you can't do that. You can't just copy one reference to another. Instead, you have to do a whole copy loop. And my brain's warping because we just did this 45 minutes ago in another class, another language. So here we have our foods, right? We're going to make another array called snacks, which is set to the same values. So find your array that says string foods. Guys, am I going too quickly? Has everybody got all this to work? Lindsay, you never tell me when it doesn't work. All right. Where were we going with that? Copying an array. We have this array called foods. Let's make another array called snacks underneath it. So, here's how not to do it. String snacks is equal to foods. That doesn't do it. In fact, it's even giving us an error. But, well, okay, we could split it into two things. String snacks, snacks equals foods. Is that going to work? No, it's just not letting us do it. what we have to do is we have to allocate this array to the same length as the other one, and then copy the elements in hand, item by item. So how many elements are in the foods array? We could just use that constant. It's conveniently declared. So string snacks num names, and then let's copy the values in from the foods into it. So for int I is equal to 0, it's going to be our regular old for loop. I is less than num underscore names, I plus plus. Snacks at element I, snack subscript I is equal to foods subscript I. That created a copy of the foods array. I made a mistake because I typed this stuff in lowercase when it should have been in uppercase. Num underscore names. What you really should do is to calculate your size based on your source array, rather than just relying on some constant. So what I really should do is be doing that trick, you know, size of array divided by size of string, or size of array divided by size of int, or whatever, there and there.
Function?
Pardon?
Is there a length function? Because this size divided by something is kind of...
You wish.
So this just doesn't...
That's yeah. Is there a length function? In Java, yes. In Python, yes. In C++, no. Which is a drag. I don't like that.
For intents and purposes, size of divided by string is the same.
It's almost the same. There are certain contexts where that fails, and that's what's really aggravating, is that we spend a lot of time telling you to do size of divided by size of, and then there are certain contexts where it fails. So in general, what you always want to do is declare constant and to pass it around whenever you need to print out your array. That's just pretty much how to do it, and I think I'm just going to stop mentioning size of at this point. Just always keep track of how many elements are in your array by defining a constant and then using that. All right, we are about done. Printing the contents of the array. We've been doing this using a for loop. For I is 0, I is less than array size, I plus plus, C out, array name, subscript I. Yeah, we're done. Or you can use a range-based loop. For data type, variable name, colon, array name, C out, that. We'll stop there.
So do you put C out underneath the snacks I equals foods I? Or would you put that outside the for loop?
Alrighty, please repeat.
So in order to print snacks, would you put that C out
Oh.
below it?
Right. In order to print out snacks, we'd have to, yeah, we could print it out as we iterated through it, or we could write another for loop.
Okay.
We could do this, you know, but normally they print out its own. And then you use a for loop. Let's use a range-based loop. What are snacks? Are they strings, doubles, floats? What data type? Yeah, they're strings. So string value colon snacks C out value followed by ENDL. That'll print it out. I'm going to run it, make sure I haven't broken the code. Yep, it still runs. Alrighty, we've talked about arrays for a couple of lectures. We need to see if we have any homework that we want to do on them.